In the previous episodes, Haleemah and ET worked with cobblestone patterns of different size numbers. First, they made sense of Amir's method with a size 3 cobblestone pattern, which was represented by the equation 3 times 3 plus 3 times 3 plus 3 plus 3 times 3 is equal to 30. They then applied Amir's method to a size 5 cobblestone pattern and got the equation 5 times 5 plus 5 times 5 plus 5 plus 5 times 5 is equal to 80. Finally, when applying Amir's method to a size 7 cobblestone pattern, they got the equation 7 times 7 plus 7 times 7 plus 7 plus 7 times 7 is equal to 154. In this episode, Haleemah and ET will work to meet the goal of this lesson, which is to generalize a relationship between the size number and the number of gray stones using Amir's method.
Generalize Amir's method. Write a relationship between the numbers of gray stones and unknown number size and the unknown number size.
So what do you think that's asking, ET?
It's asking us to generalize it, which means that we're going to have to put variables in place in Amir's method to make it so we can use it for any size number.
Yeah, so and just be sure to define your variables and talk together, and let me know if you need to look back at any of your work or if you need me to copy and paste anything in for you.
So now, Haleemah, ideas for the variables?
We could just use X.
For the sevens?
Yeah. I'll show you what it would look like. So it would be equals, I guess you can do T for total.
Sounds great.
Oh, I put 7 for those X's.
So I am going to type out what X means. Do you want to tell me what X means?
Okay, X is the unknown value of the gray stones, or the unknown number of gray stones.
That sounds great.
Okay.
And T would be the total, you said?
Yeah. You want me to write that, or you're already writing it?
I got it.
Okay.
So ET, can you start us? Just tell me about your equation.
So the generalized one or Amir's original?
The one with the X's there. Can you tell me about that equation?
Yes. So this equation, we have x times x plus x times x plus x times x equals t. And x would be the unknown value of gray stones. And the t represents the total number of gray stones.
Thanks, ET. Haleemah, do you want to add anything to that?
No, that sounded good to me.
So when you say X is the unknown value of gray stones, when X was 7, what did that mean here? What do you mean by the unknown value of gray stones?
Like if we didn't know this was 7, or if this wasn't 7, like.
Or the correct term would be the unknown size number.
Same word, ET. what relationship are you seeing between the size number and some number of stones in the figure?
For all of Amir's methods so far, the x would be the size number, like right here. That would be the same as right here. And for all the rest of the equation.
What do you think, Haleemah?
I think the unknown value could be the size number or like the stones since they're the same
Which
far.
all of the stones?
Or just I guess any gray stone. It works.
Any gray stone. So if I point to a gray stone, one gray stone is
Any column of gray stones. But
okay.
I think the size is less confusing.
So what would do you want to make any changes here for the X? I've heard you thought it could be two different things. Maybe you could explain what the X could be.
We could put gray stones in one column, or we could put the size value. I mean the size number.
Well, both sounds like great ideas to me, so I'll put them both. Does that work with you guys?
What do you think, Haleemah?
Yeah, that works.
There are a lot of great ideas in this episode. First, Haleemah and ET made quick work of writing their generalization using algebra. They found that Amir's method generalizes to the quantity x times x plus the quantity x times x plus the quantity x times x is equal to t. Then Haleemah and ET had a little difficulty thinking about what each variable represented. T was a total number of gray stones. That seems to match Amir's method. But what about x? What does x represent? At first, Haleemah and ET said that x was the unknown value of gray stones, but that sounds a lot like what they called t. Haleemah remembered that in the size 7 cobblestone, x represented a size number of 7, but also the number of gray stones in each column. Both sounded great to ET, and me too. Remember, Amir's method had the same number appear in a number of spots, and that can make defining our variable difficult. In the next episode, Haleemah and ET will use their general equation to find the number of gray stones in a cobblestone of a new size number.